point, we have learned how to solve one variable equations. We have learned how to do multi-steps. We have learned how to use the distributive property to help us solve. We have learned to move variables or from opposite sides of the equal sign to the same side. We have learned how to use different properties of fractions and decimals to help us solve equations that have fractions and decimals in them. We've learned how to solve cross products. We've actually learned how to move values back and forth across the equal sign in multiple ways. And therefore, we actually don't necessarily need to know what those values are to continue using those steps. So, for example, these equations have no value to them. I made them up, but imagine that each one of these variables has some type of value. We don't know what it is, it's a number, but we're just going to treat it as a uniform variable. So what I mean by that is, for example, in the first equation, it says R is equal to T plus M. So I don't know what R is or T is or M is, but it is a real number. And I want to solve for T. That's why I wrote for T there. And so what I'm going to do is move these variables the same way that I move around real values. And so if M is being added to T, then what I'm going to do to move T away from M, because remember when we solve for a variable, we get it by itself. So I'm going to subtract an M on each side. R minus M, these two values cannot be combined because they're not like terms. We don't know what they are, so all we know is that they are R minus M. On this side, the M's subtract out, so what we're left with is T. And so now I have solved for T, even though I have no idea what these quantities are. So let's take a look at this one. Here we want to solve for y. Here we have y in the denominator of x, so I definitely need to make it y over 1, which is what we have here on the right. And so what I'm going to do first to solve is to multiply by y on both sides. Now, normally, or we could say we're multiplying by the reciprocal of 1 over y. When we do this, okay, so now we get y over y, because we have y over 1 times x over y, so y divides into y and becomes 1. So we're left with x equal to 3y. And so now, since we want to know what just y is, and 3 is multiplying times y, I'm going to divide by 3. And so regardless of whether we know what x is or what y is, we know that if we had those quantities, if we knew what x is, we would know what y is. And it's x over 3. Okay, so this one here on the upper right-hand corner, it has a few more steps to it. We're going to solve for x. This is a quantity in the numerator of the fraction, and it's being multiplied together. So first, what I want to do is take care of this denominator. I can't actually separate out the b at this point. So I'm going to do that by multiplying both sides by y. So now y and z, I don't know what they are, but together I just get yz. On the right-hand side, I get 1y, or y over 1, times bx over y, so the y's divide into each other. So I'm left with b over x. And the last step, to get x by itself, we have b times x. Well, down here before, we did 3 times y, so you can imagine b is could be the number 3. But regardless, so we're going to divide by b because it's multiplying times x. And so we're going to divide this side too by b. And so what remains is that y times z divided by b equals x. So each one of these steps we've done before, but we've had more literal, not literal equations, but more real valued equations and only one variable. So this last example I want to show you here. Now we want to solve for n. So it's at least a two-step equation, correct? This is just a two-step equation with four variables in place of the values. So we always do addition, subtraction moves first. So this c is a positive c being added to n over d. So I'm going to subtract a c from both sides. So on the right-hand side, c minus c is 0, which leaves me with n over d. And on the left-hand side, w minus c, they're not like terms, so I'm just left with w minus c. And finally, now we're close, we have n in the numerator and d in the denominator, so let's multiply both sides by d. Now, when we multiply both sides by d, remember that this quantity, this is one quantity, so when d comes and multiplies on this side, it will be multiplying times the total quantity. On this side, we get d over 1 times n over d, so the d's, again, they cancel out. And so I'm left with an n on the right-hand side. And if you want, you can leave this like this, or we can multiply out the d by the distributive property. And so we would get dw minus dc. Um, so the second part, I wanted to show you some more multi-step solvings of literal equations. If we look at the first example, we have h equals f minus e divided by f, and we want to solve for f. So this is a little bit more tricky. So the first thing that we want to do that we can do is that if we look at, first we want to talk about the fact that this numerator, remember this f minus e, this is one quantity. So what we're going to do is what we can do first, and that is to multiply both sides by f. So remember, by multiplying by f, or the denominator, on both sides, these two denominators, they cancel each other out and become one. So now on the left-hand side, I have, I'm going to write it HF. And on the right-hand side, I have F minus E. So have I made anything better? Well, kind of. We still have an F on this side and an F on this side, and these are actually attached, aren't they? So what I'm going to do is I'm going to subtract F to the other side of the equation. And so now I have on this left-hand side HF minus F, and on the right-hand side I have a negative E left over. So here we have the two F's. These are actually not, it's not possible to combine them because this is HF and I'm not really sure what that quantity is, and this is a negative 1F. What I can do though is that both of these numbers have a common multiple of F. So what I'm going to do is I am going to factor out an F from each one. And this is what I call the reverse of the distributive property. Remember that we said that in the distributive property that if we have A times B plus C, right, equal to AB plus AC, then all I've done is this is what I started with, AB plus AC, or HF minus 1F, but well, and it's a minus sign, but that must mean that if I have a common multiple, that I can factor that out to the front and reverse the distributive property. Now I have one F term by itself times H minus 1 equal to negative F. So let's write that up here. I thought I had enough room. I don't, so I have F times H minus 1, which is equal to negative E. So given that H minus 1 is one quantity, multiplying times F, I'm going to divide both sides by H minus 1. On the left-hand side, these two quantities are actually the number 1 because they're exactly the same. So what's left is just the F by itself. And on the right-hand side, since these are variables that are unknown, we're left with negative E over H minus 1. And so this is our solution. F equals negative E over H minus 1. So I'm going to take my eraser and no, I think we have room to do this second one down here. I'll change my color pen so you can uh, see the new work. Okay, so in this case, we have 4t equal to negative 4r plus 2a, and we're looking for t. So this is a little bit simpler. What I need to do is get the t by itself. 4 is multiplying times it. So what I'm going to do is I'm going to divide the entire equation by 4. On this side, these two 4's cancel out, and I'm left with the t. And on this side, actually, this quantity being added over 4 is the same as negative 4r over 4 plus 2a over 4. That's what happens when we have a common denominator. They are equivalent. And so if we have negative 4 over 4, what I'm left with, I'm left with a negative r plus, and then 2 and 4 reduced to 1 half. So I'm left with negative r plus 1 half a. And now we've solved for t. Okay, so I hope you're pausing and going through these steps and taking a look at them. If you have any questions, please bring them to class. Let's look at this last example I have in the upper right-hand corner. In this example, we have negative 2m minus 3 over km, and we're going to try to solve for m. So I wanted you to think about the ways that we've done the previous two examples, how we have done that. In the first example here, we had f minus e over f. So here we have an m over m. We're going to do some of the same process. In fact, the first thing we're going to do is we're going to multiply both sides by km. Just going to move the whole piece over here to km, whatever that quantity is. So on the left-hand side, I end up with kmx equal to, and these cancel out. That's why we multiplied by both sides by km, so we could have them reduce. And so we're left with negative 2m minus 3. So again, I have the m's. They're not together. They're on opposite sides of the equal sign. So I'm going to think of that first problem. Let's go back and look at what we did with f. We brought f over by subtraction. So here, I'm going to bring over plus 2m by addition. Now, why the 2m and not just the m? Well, the 2 is attached to the m by multiplication, and the only way it can be separated from the m is by division. If we divide negative 2m by negative 2, then we have to do that also with negative 3 and kmx, and which is much more complicated. So we move these variables with a coefficient in one move by addition subtraction. That gives me 0, and on the left-hand side, I'm left with kmx plus 2m equal to negative 3. Now, thinking of this first example, we'll do the reverse of the distributive property. Each one of these terms here has a common factor of m. So m I'm going to pull out in front, and I'm going to leave behind kx plus 2. In that way, when I do the reverse of this distributive property, I know if I multiplied out this m by the distributive property, I would get back to the original equation. We have to keep that value still there. And then it's equal to negative 3. So the last step would be to get m by itself. We divide the whole quantity on this side by kx plus 2. And then we divide negative 3 by kx plus 2. And so kx plus 2 over kx plus 2 is 1, so I'm left with m. On the right-hand side, I'm left with negative 3 over kx plus 2. That's our final answer. So, as you can see, we have all the tools to solve complicated equations like this. We just stick to the basic rules and move our quantities around, and we can isolate the given variable and solve for it. All right, thank you very much. Answer the 2 questions, please, and email them to me as usual. And I will see you tomorrow in class.